In this exercise, we will get introduced to the concentric mate. What the concentric mate allows us to do is to align the two axes of cylindrical symmetry. So essentially to put like the bolt in a hole. So we are going to do the exercise on a page 310, 5, 7. We are going to make a 3 parts, which we are going to mate then. Okay, so let's see the block bottom. So we will start by making a block bottom part, and this part is in a MMGS unit. So set it to millimeters. Probably the most efficient way is to make a rectangle of 60 by 40. 60 by 40, and then we can make another rectangle inside with a like this, where the length of the rectangle, inner rectangle, is going to be a 20, and the top and bottom distance is going to be a 10 and 10 millimeters respectively. And let me show you here a technique of the master sketch. So this master sketch we will use to produce two extrusions. One which will be a 15 millimeter thick, and that will be the entire block. And then second one which will be a top, which will be a total of 30 millimeter thick. How can we do this? We will use the one sketch to make the two extruded boss features. So we will make the first extruded boss feature, which will just choose the whole sketch, and the thickness of that first feature is going to be a 15 millimeters. And click OK. However, from 3 now the sketch is apparently consumed. It is not. It just became a part of this boss. Watch this carefully. It is not in a book. I will click on the arrow. I will right click on a sketch, and I will left click on an eye. So again, what I will do, I will click on the arrow in front of the boss extrude. Then I will right click on a sketch, and I will click on the eye to make it to a shove. That way, look what happened. My sketch is now shown. Now I can reuse this sketch and its features to build the next part. So I'm going now to choose the inner contour, and I'm going to extrude that inner contour as per my drawing to a 30 millimeters height. And look, I used a single sketch to create that. Now to finish this part, what I need to place hole. And I will use the hole wizard. And this is 15 millimeters hole, 515. Try the unsymmetric. It will be here actually somewhere. Well, unsymmetric does not have a 15. Let's see if the DIN has a 15. If not, then we are going to make a 1. Nope. So then we need to go to what? We go to a generic hole. Simple. And in a generic hole, we can specify whatever we want for a diameter, 15. True all. Then I position the hole on this surface, and I'm going to dimension the hole to be a 15 and 20, and that will 15 and 20. And click OK. And here is my part made. I save this as a block bottom. Block bottom. And this will be under the ENGT131, but on the... Where is my other drive? Okay, so it is under ENGT131 block bottom. Now I'm going to make the block top. And do you see some similarities with the block top and block bottom? Who can tell me what are the similarities between the block top and block bottom? Both have the same dimension. What is only difference? Yeah, the other recess, hole. So maybe we can actually then do this. Do I need to draw everything again? No. So what I will need to do, there are two different ways. I will not introduce you yet to a configuration, but I will introduce you to something else. I will introduce you on how to derive one part to another by saving. I will save this part, save as block top. And now I'm going to delete my boss extrude tool. So I save it under different file name, deleted boss extrude 2, and what I need to do? Need to do the cut. True all. And look at this, with a 3-click of the mouse, I have created second part. How cool is this? I don't need to redraw everything. Another way to do this will be to open the sketch, Ctrl-C to copy all the sketch, and then Ctrl-V to paste it into the new part. Okay, so we created the block bottom. We have a block top. And we have a block bottom also. Let me file open block bottom. So we have now those two. And what is the last part that we missed there? Pin. And to make that pin, the post, that's 515 post, I'm going to just make a one rectangle. And I'm going to specify a center line. And I'm going to make the rectangle length of the pin, what is a 30. And I'm going to make the diameter by clicking on the outside to be what? 15. Now I'm going to, in a features, to do revolve. Click OK. And what else is missing here? Chamfer. So under fillet, press on arrow, press chamfer, and this is a 2 millimeters. I did just a one mistake. What did I just do here? IPS. So now this is 25.4 times larger. Well, have two options. What will be the simplest way to save this? How about if I scale it for the 1 over 25.4? Yes. So features. If I go into the features, insert, actually, let's see. There is a scale option. Features, where is the scale here? Where?
Go where you are. Go right. It's under rib.
No, the rib. Oh, here, under rib. Okay, scale. So 1 divided by 25.4 uniform scale. And look at this. Now my part is in a millimeter. And if I evaluate it in a millimeters, 30 millimeters. And
one more time, can you show where you...
yes. Okay, so I will delete the scale. So now this part is a 25.4 times larger. So how can I scale it down? I will insert scale feature. Insert feature. Yes, scale. Around centroid, and this is the conversion factor, how I know it is a 1 divided by 25.4, because there is a 25.4 millimeters in a 1 inch. And I click on a feature, and that's it. And now I can insert my chamfers. 2 millimeters at 45, and I will choose my two edges. and I will save this as a 515 post. The 15 post. Now I'm going to make an assembly and to demonstrate to you the center, the centered mate. So we will go to a window of my block bottom because that's my base. Going to make file, make assembly from part, block bottom, click OK, and I brought it in. Now I'm going to insert two other components. Go to insert components, insert components. I will insert the block top somewhere, and I'm going to insert pin, the 15 post. Doesn't matter where, and orientation, okay? And I'm going to make this to float, others float. Okay. Here are now my bin of parts, and what I need to do next. I need to mate them. The mate that I want to show you today is the center mate, the concentric mate. Concentric mate is this one here. For the mate selection for a concentric mate, we need to take cylindrical or conical surface or any surface which has an axis of symmetry. So I will choose the cylindrical surface of my pin and where I want to mate it, with the cylindrical surface of the hole. And look what has happened. Now this pin is aligned with my top hole. So those two are now aligned. Now I will do it again, and I'm going to mate concentric. I will mate cylindrical pin with what? How about if I mate it with another hole side, the other part, and that's not tangent, that should be concentric. So mate concentric, click OK. Now I can't move this part anywhere, but I can still rotate it. So what I need to do next, I will use the mate which we learned last time, which is what? Coincidence. So I will click on a coincident. I'm going to glue the top piece to the bottom piece. Click OK. And I'm going to mate, let's say, the front and front together. Click OK. That's enough of mating this one. And last mate will be a top of the cylinder to a top face here. And I can also click here OK. You see that it is still underdefined, although nothing can move. But there is one thing that can move. Who can tell me what can still move? The pin can rotate. So if we now open the mates, and if we check any of those concentric mates, let's say edit feature on a concentric mate, there is a box which says lock rotation. If I click on a box to lock rotation, look what will happen. It will change to a fully defined. And now if I grab it, I can't turn that pin. So it will be kind of like, let's say, a pressed fit pin versus the loosely fit pin. And here is your full assembly. If I do like the cross-sectional view, here is how it looks like. That's exactly what it should be. And those are net parts. As you've seen, there is a considered ideal fit here. Okay, we can close the sectional view. Assembly, we can also add some stuff here to the assemblies on annotation side. How about what is the most important? How we reference parts in assembly based on the numbers, like the part 1, part 2, part 3. So we need to create a balloon. So let's see, where is that? If I go to insert, And if I go to annotation and I click on the balloons, balloon text, okay. We should go with the auto balloon. Okay, that's my one. I just click on a piece and it will tell me the balloon. I will delete this balloon because we have a duplication. So look, now it tells me part 1, part 2, part 3. I can insert under the tables bill of material, part level. We will go through the bill of materials. And look what I got here. I can actually insert table even into the assembly mode to help me as I continue assembling it. Okay, so this concludes this demonstration. Today, in these 15 minutes, we learned how to use the concentric mate. We learned how to reuse the part to create a second part by saving it. We will learn again this, how to do with configurations. And what else did we learn? How to fix the part if by error we do it in a different unit systems, like how we can convert part from inches to millimeters or from millimeters to inches. This concludes this demonstration.